Hello and welcome to Sudoku. This is a Kropki Sudoku puzzle that was set by Richard Stolk from the Netherlands for the round 5 of Sudoku Grand Prix 2021. And it was the highest pointer in the round, and I found it to be so difficult that I did not manage to solve it during the contest. And I had some trouble solving it afterwards, and I hope I'll be able to solve it again, because I remember it was quite messy. Well, my solve was, I'm sure I missed a lot of the intended logic, but well, anyway. So what's the point? Well, whenever you have a black dot, it means that one of the digits is double the other. Whenever you have a white dot, it means that both digits are consecutive. And whenever you don't have a dot, it means that neither of those properties apply. And that's it. And classic Sudoku rules, obviously. So where do we begin? Let's just note that a black dot means 1 and 2, 2 and 4, 3 and 6, or 4 and 8. So those are the only digits that can go into those cells with a black digit. And therefore we can already know that these 3 cells can only contain 5, 7 and 9. Now on this row we know that those are consecutive digits, so there must be an odd digit and an even digit. Same here. So one of them must contain a 1 and the other must contain a 3. And 1 will come with 2 and 3 will come with 4, meaning that the remaining 2 cells must contain 6 and 8. Where do we look next? Well, some places of interest are there, here and there. For example, we don't know that much about this. Let's have a look at this. So we know that those pairs are different pairs with different digits, and that those digits are consecutive. And it couldn't be a 1 here. Oh, sorry. I mean that this must be an odd digit and an even digit. And the odd digit couldn't be 1, because 1 here would need a 2 here and a 2 there. So it has to be a 3 together with a 2 or a 4. So we get a choice. One of them is a 3 and the other one is a 2 or a 4. And then in the same column we still have this. And we know that 5, 7 and 9 must appear in 3 of those 4 cells. And 7 cannot appear here because there would be a white dot otherwise. Okay, so what about this? Let's imagine that those are 3 and 6. Then you see that this is not a 3, so 3 will have to go there with a 6. And there we need to put 3 and 6 there. And whenever you put 3 and 6 there, seeing that there are no dots, no black dot, they must be separated by a cell. But then 6 can't go here, so 3 has to go here. But without a black cell, this can't be a 6. But this can't be a 6 either. So this option of 3 and 6 here is eliminated from the start. So those must be digits between 1, 2, 4 and 8. That is powers of 2. And let's have a look at how they are, well, which one they are. This one can't be a 1 for the same reason as here. Those would be 2s. So this must be 2, 4, or 8. And those ones must be powers of 2 as well. And what can we do? Well, what I thought was 8 would be the easiest to eliminate, because 8 would force those two to be 4s, would force this to be a 6, and that would put some pressure on all of this. So let's assume this is an 8, that's a 4, that's a 6, and now this one can't be a 3 because it would put another 6 here, so it has to be a 2, so that's a 3, that's a 6, that's a 1. So now let's hope that this breaks, and indeed, I seem to remember it does. Okay, so where do we put 7 and 9? 7 and 9 can't go here, so this is either 3 or 5. This can't be a 3, this can't be a 5 or a 7, it has to be a 9. But then 3 doesn't go here, 5 doesn't go here, 7 doesn't go here, it doesn't work. No digit is available for this cell. Well, that's a bit complicated, but then it's a 95-point puzzle, so it was bound to include some difficult step. So now this one is 2 or 4, and this one must be, well, some digit. And after a few tries, I wondered whether this could not include a 3. Could this be, well, it couldn't be 2 and 4 because of this. So if this is not a 3, then this must be either 1 and 2 or 4 and 8. And let's try 8, 4. Then I get 2, 1, 6, and I think I remember I stumbled on the same kind of issue. Because where does 3 go? Not here, not there, not there. 5 and 7 are forbidden from here. So this is 9. I get 7 here, 5 there. But then I get 3 here and 6 there. And this is where it breaks. That's complicated as well, but it works. So this is not 8 and 4. And let's try 1 and 2. And this is 4, this is 8, this is 3, this is 6, this is 6 as well. And where does 3 go in the column? Not here, not there, not there. 3 goes here. And where does 5 go? Not here, not here, not there. So 1 and 2 are impossible as well. And we now know that this is a 3-6 pair. With 3 here, 6 there, and 8 on top, a 6 there. And this 8 removes 7 and 9 from this cell. Plus this one can't be an 8, so it has to be 1, 2, or 4. This is 2 or 4. And this will be 1, 2, 4, or 8. But let's have a look at this. These are 3 consecutive digits, and they don't include a 6. How many even digits are there? It's either 1 in the center and 2 odd digits around, or 2 even digits here. But 2 even digits separated by 2 can't include an 8, they must be 2 and 4. But if I put 2 and 4 here, then there's a 3 here and it breaks. So no, there can only be an even digit here. And which one will it be? Definitely not 4, because then this would have no value. 5 would break, there's no white dot, and 3 would break, obviously. So it must be 2 or 8. But we see that 2 breaks as well. If I make this a 2, I do this in red, then this is 4, and this has to be 8. This has to be 1. But then we need to put 7 and 9 in this box, and they can't both be next to 8, so they must both be here, which is not allowed. So the only option is to put 8 here, surrounded by 7 and 9, but 7 is not next to 6, so that's a 9, that's a 7. And then comes the question of what happens here, and I don't think we can rule this right now. Okay, so where should I look next? Probably at this column, or perhaps this one. What are the options here? Okay, so 2 is not an option because one of those two cells contains a 2. If this is a 4, then this has to be a 2. 1 looks possible. 5 looks possible. 7 and 9 are not. This one is not 5 or 7. It's not a 2. It could be a 4. I don't think that's the right place to look. Let's have a look at this column, I think. There's something about this I seem to remember. So this one is a power of 2. And it's not a 1 because I would have 2 and 2 here. So it's 2, 4, or 8. And now my question is, what's here? What's up there? If this is a 4, or rather, where are 7 and 9 on this column? 7 and 9 are not here. They are not on those Kropki black dots, so they must be here and there. So 7 and 9 are here and there, and now I know that this is an 8. Together with another 7 or 9, and this gives me this 4 and this 2 and 3 or 5 here. All right, so now here in this column I still need 1, 2, 4, 3 and 6. This is not 3 or 6. Obviously 3 and 6 are on some Kropki pair. This one can only be a 6. 1 and 4 are not possible because of these 2. 3 is not possible because of these 2. This has to be a 6, so this one is a 3. And I get 1, 2, and 4 up there. So this is either 1, 2 or 2, 4. But here we have 3 disjoint pairs, meaning that I can't have 2 and 4, because then 1 and 8 would have no possibility here. So this is 1 and 2, and this one is a 4. And 1 and 2 can't be next to the 4, so I get 2 here, 1 there. 2 removes 1 from this cell. Now this column 1 is not here, not next to the 2, it's here. And 7 and 9 go this way. And from that point on, the rest of the solve should be much smoother than what I did earlier. And I guess there are better ways of solving it, but well, that's the way I found. Here we still need to put 3, 6 somewhere and 4, 8 somewhere. And you see that 8 can't be on top, can't be next to a 7 or a 9. So 8 must be down and 4 must be up. But 4 can't be next to the 2, so I put 4 here, 8 there. 3 can't be here, so 3 is there, 6 is up there, and it removes 7, and we get this pair. Here we need 2 consecutive digits. There has to be an even digit. It can only be a 2. 2 is not next to the 4 or to the 3 for that matter, so that's 2 and 1. This is 8 or 6, but because of this 6, it's an 8. So, sorry about that. 7 is not here, not there, so it's here. I get this 9 and this 7. 2 is not here nor here. Those are 4 and 5, and because of this 6, I put 5 here and 4 there. 6 and 9, by the negative Kropki rule, they are put this way. 1, 3 are not here, so this is 5. 3 is not next to the 4, and I get this 5. Here, not using 1, 3 or 8, there must be 2 and 4, but 4 is not next to the 8. 2, 4. So I need to put 1, 2 and 3, 4 up there. So now this is not 1 and 2. 3 is not next to the 6. So those are 1 and 2. Here I need a 1. It's not next to the 2. I need 6 and 7. And this 6 disambiguates. Here I need a 5. It's not next to the 4. And a 7. I need 8 and 9. They are not next to each other. 8 is not next to the 7. And a 5. No, not a 5, sorry. That's a 3. And the 3 disambiguates the 1, 2 pair. Okay, so we still need a 5 and a 3. 3 is next to a 4 because 2 is already taken. That's a 2 now. 1 is not here, 1 is not here. I still need a 9. It's not next to the 8. 5 here. 1 and 4. Down there, a 7 and an 8. 8 is not next to the 4. I still need 3, 6, and 9. So this is 3 and 6. And because of this 6, that's 3 and 6. And I said 3, 6, and 9. So this is 9, this is 3. Consecutive, there's a 4 here. So 2 here, 4 there. Let's now get an 8 and a 5, a 2 and a 6, and then the remaining digits are 8, 6, 9, 7 at the bottom, and 1 here. So that finishes the solve of this really difficult Kropki Sudoku by the professor, and I think I missed some much more elegant logic. My eliminations were, well, some of them were, I'd say, really nice. Some of them were a bit long to my taste. But then, like I said, I probably missed some much more elegant logic. And please write them in the description. Write them as a comment under the video. Thanks for watching this video and see you soon on Sudoku Canard.